Welcome to ACS Sityawan channel. I'm Miss Karti. Today I'm going to teach on the ladder in equilibrium position, which is the subjects for lower 6 physics. Today I will explain or share on how to draw the forces involved in a ladder and also the solution. Okay, first if you see here the diagram, okay, this is the ladder and it's lie on two surfaces, which is one is smooth, one is rough. Okay, as we know, when there is a rough surface, it will have a frictional force. Okay, so where is the direction of frictional force? So, okay, we see here, the ladder is lies here. Where is the probability of the ladder to move or slip? Yes, it will slip to the left hand side. So the friction will against the movement, so the friction will occur on the right hand side. So here I label as Fs for frictional force. Okay, the second force is the weight. Okay, where is the weight? Okay, the weight will act on any object which is at the center of the object. Okay, let's say this is the object. The weight will occurs at the center of the object and it will towards the downward. Okay, this is really the weight if it is on the flat surface. If let's say this object we put on the inclined plank, okay, for example this is the object, the weight will incline according to the plank inclination with the same angle with the surface of the inclination, which will have the same theta here. Okay, I think this is we already learned before. So the same concepts goes here. Here we have a ladder, so the weight of the ladder will be inclined because the ladder is light on the surfaces, so the weight will be here. Okay, here will be theta and we can draw the normal line to the surface. This theta also will be the same with the inclination of the ladder. Okay, so we already have two forces. The third forces and fourth forces from the third force and fourth force from the surfaces. According to the Newton's third law, for every action there will be a reaction, which is because of the ladder lies on the two surfaces, we will have two reactional forces. Okay, which is on the surface of A, okay, and also surface of B. So here I use R, okay, I label as RA and RB. Okay, some books they will use N, okay, for normal reactions, so it doesn't be a problem, either you use R or N. Okay, so there are four forces in our diagram or system. Okay, there's all forces acting on this ladder system. So simple. Okay, now we go for the solution. Okay, for the solution we have three conditions. Okay, what is the first condition? First condition is the sum of horizontal forces or Fx equals to 0. Okay, what are the forces horizontal in this system? Okay, before that we have a direction. Force is a vector quantity, so it has a direction. So how we determine the direction? We use a simple method. This will be y positive, this will be negative y. Okay, right hand side will be positive x, left hand side will be negative x. So here Fs is the horizontal, first horizontal force, so it's going to the right hand side. So right hand side will be positive, so I put positive Fs. Okay, the second horizontal force is Rb. Rb is going to the left hand side, so left hand side will be negative, equals to 0. So Fs equals to Rb. Okay, so before we solve this, I give some one example, so then we can see the number, okay, the answer. Okay, let's say the weight is 100 Newton and the theta is 30 degree. Okay, so here will be 30 degree too. Okay, so we resolve. Okay, it's okay. Okay, the second one will be the vertical force. Okay, vertical force, the sum of the vertical force or sum of Fy equals to 0. That is the second condition. Okay, we see what are the vertical. Vertical means y. Okay, so here the y is, first force is Ra. Ra is going to upward. So positive Ra. Okay, the second one is W, weight is going downwards. So downward will be negative, equals to 0. So Ra equals to W. So W is already given the value, so we can solve this. 100 Newton, yes, correct. Okay, third one. But still we cannot solve the Fs and Rb. So we go for the third condition, which is sum of the torque equals to 0. Okay, what is torque? Torque is work done in a rotational body or rigid body. Okay, so there is a formula for this, which is F times perpendicular distance. Okay, torque is equals to, torque is equals to F times perpendicular distance. Okay, so how to find this? So force and the distance must be perpendicular. Okay, let's say we take this ladder as the distance. So the distance between the weight and the, A will be the distance. Okay, before we proceed with the torque, we must put a fixed point in this ladder system. Why we must fix? So then only we can determine the distance from that position. So here I choose A as the fixed point, okay, or hinged point or pivot. Some books they use pivot. Okay, so if I take A as a pivot or fixed point, Fs and Ra will have a 0 torque. Okay, why it is 0 torque? Because no distance from A, 0 distance. So when 0 times with the force, it will give the 0 torque. Okay, so we have only weight and Rb, which have the torque. So, okay, so we know already got 2 torques here, so we have to find the values. How to find the second? We have to see F is perpendicular to the distance. So we see here, the weight and the ladder is not perpendicular, but we have one method to find that. Okay, which is, we can resolve this weight to here. So this part or this side is adjacent to the angle. So if adjacent, W cos theta. Okay, so W cos theta is now perpendicular to this distance. So how much is this distance? If the length of ladder is L, this will be half L. So now we have force and the distance. So we can find W cos 30 times L over 2. Okay, and then another one is Rb. Okay, Rb also we must have a perpendicular. So we draw the normal of perpendicular distance. So this angle will be same with this. Okay, can you see here? This is Z. So the angle here is the 30. Here will be 32. Okay, so this surface is similar to here. So opposite will be RB sin theta. So RB sin 30 times the distance here will be L. Okay, equals to 0. Okay, but if you see here, I never put the sign positive, plus or minus. Okay, there is a condition for that. Okay, for the torque also is a vector, so we can find if it is clockwise will be negative torque, anti-clockwise it will be positive torque. Okay, so we see how is the anti-clockwise or clockwise. Okay, we see the force here. This is the force, right? W cos theta. Okay, we use the right hand grip rule. Okay, we put at the force, and then this is the distance, right? So we move curve here, curve, and then it is moving to the clockwise. So if clockwise is negative. Okay, this is the RB and this is the distance. So we curve here, it will be anti-clockwise. Okay, so anti-clockwise will be positive. So here I can solve. RB equals to, I bring there W cos 30 times L over 2. I bring here, and then sin theta I divide here. Sin 30. Okay, and also L. Okay, I just leave the RB here, and the rest I bring to the right hand side. So I can cancel here. L. Cos and sin can be tangent or cotangent. So 100 to cos 30 over sin 30. So you can press the calculator, you will get around 86.60 Newton. Okay, so now we get the value of RB. Okay, we go back to the first condition where Fs equals to RB. So we have got the solution already, which is Fs also 86.60 Newton. Okay, that's all. We got solution for Ra, W, RB and Fs. So actually ladder is very easy if you really understand the concept of direction, the resolution, and also these three conditions. Physics will be very fun if you really like that and explore it. Okay, that's all for today. Please like, share and subscribe ACS Setiawan channel. Thank you.